Hello everyone, I am Sandeep. I am here to discuss about curl of the vector. Let us understand about curl of the vector. After divergence, the second operation on vector field that we examine is the curl, which measures the extent of rotation of the field about a point. Suppose that vector f represents the velocity of a fluid, then the curl of the vector f at point P is a vector that measures the tendency of particles near P to rotate about the axis that points in the direction of this vector. The magnitude of the curl vector at P measures how quickly the particles rotate around this axis. In other words, the curl at a point is measure of the vector field spin at that point. Visually, imagine placing a paddle wheel into a fluid at point P with the axis of the paddle wheel aligned with the curl vector. The curl measures the tendency of paddle wheel to rotate. Consider the vector field in these figures. Part A shows the vector field is constant and there is no spin at any point. Therefore, we expect the curl of the field to be 0, and this is indeed the case. In part B, it shows a rotational field, so the field has spin. In particular, if you place a paddle wheel into a field at any point so that the axis of the wheel is perpendicular to a plane, the wheel rotates counterclockwise. Therefore, we expect the curl of the vector field to be non-zero, and this is indeed the case. To see what curl is measuring globally, imagine dropping a leaf into fluid. As the leaf moves along the fluid flow, the curl measures the tendency of leaf to rotate. If the curl is 0, then the leaf doesn't rotate as it moves through the fluid. Definition of the curl is given here. If vector f is equal to p, q, r is a vector field in R3 and dou p by dou x, dou q by dou y and dou r by dou z all exist, then the curl of the vector f is defined by dou r by dou y minus dou q by dou z into I cap plus dou p by dou z minus dou r by dou x into j cap plus dou q by dou z minus dou p by dou y into k cap. Note that the curl of the vector field is a vector field in contrast to divergence. The definition of the curl can be difficult to remember. To help with remembering, we use the notation del into f vector to stand for a determinant that gives the curl formula. Here is the matrix representation of the curl. In this slide, discuss the determinant of this matrix. The determinant of this matrix is dou r by dou y minus dou q by dou z into I cap minus dou r by dou x minus dou p by dou z into j cap plus dou q by dou x minus dou p by dou y into k cap, which is equal to curl of the vector f. If f vector is equal to p comma q in vector field in R2, then the curl of the vector f is defined by dou q by dou x minus dou p by dou y into k cap. Let us discuss about finding the curl of the three-dimensional vector field with an example. This question says to find the curl of the vector f of p comma q comma r, which is equal to x square z comma e power y plus xz comma xyz. On applying the formula we discussed previously, we get the equation. Here in this equation, xz comes after differentiating partially r with respect to y, and this x comes after differentiating partially q with respect to z, and this x square comes after differentiating p with respect to z, and yz comes after partially differentiating r with respect to x, and z comes after partially differentiating q with respect to x, and after partially differentiating p with respect to y we get 0. This is the final equation for the given vector f. There are wide range of applications on the curl of the vectors are there. Let us discuss some of them. First one is fluid dynamics. The curl of a velocity field in fluid dynamics helps describing the circulation and velocity of a fluid. This is crucial in understanding the behavior of fluids in situations like airflow around aircraft wings, ocean currents, and weather patterns. Second one is electromagnetism. In electromagnetism, the curl of the electric field gives rise to the magnetic field and vice versa, as described by the Maxwell's equations. This is fundamental to the behavior of electromagnetic waves, antennas, motors, and generators. Third application is astronomy and astrophysics. The curl of a magnetic field plays a role in behavior of celestial bodies such as stars and planets. It's involved in the dynamics of solar flares, the Earth magnetic field, and behavior of the magnetized celestial objects. Fourth application is computer graphics and animation. In computer graphics, the curl of a vector field can be used in simulation of realistic fluid motion like smoke, fire, and water. It is used for creating realistic hair and fur simulations. Fifth application is material science. Understanding the curl of stress and strain fields is important in material science for analyzing the behavior of materials under different conditions, which is critical in designing and optimizing materials for various applications. Here are some more applications on curl of the vector field. Fifth application is seismology. The curl of displacement or stress field is used to study seismic wave propagation and earthquake dynamics. Understand how seismic waves interact with complex subsurface structures. Sixth application is image processing. In image processing, the curl can be used for edge detection and feature extraction. It helps identify regions of rapid change in intensity, which can be useful in image segmentation and object recognition. Seventh application is robotics. The concept of the curl can be applied in robotics for tasks like motion planning and manipulation. It helps in analyzing the controlling the rotational aspects of robot motion. Eighth application in fluid mechanics in engineering. Engineers use the curl to analyze fluid flows in various systems, such as designing efficient pipelines, optimizing heat exchangers, and understanding the combustion process. Ninth application is climate science. Curl calculations are important for studying large-scale atmospheric and ocean circulations, which play a significant role in climate patterns and global climate models. These examples highlight how the curl of a vector field is a versatile mathematical tool that finds application in various scientific, engineering, and practical domains.